There you go. Before we get any further, just to walk you through a little bit of the sort of how we're going to handle tech support here. So there are a couple of people in the chat. I'm not one of them who can help you with RStudio. And so we invite you, if you're running into challenges, to start by asking a question in the chat. I am also right now going to be launching a breakout room. And so it's open throughout the session. It's going to be open, but we're suggesting that people only use it if they have a really thorny issue that they need to handle. So if you run into a big problem that you can't handle through the chat, then let someone know in the chat, say, I'm going to jump into the breakout room, and someone will join you and hopefully try and work things out that way. I think that's essentially all I have to say. So now without any further ado, I will say, if you're confused about the breakout room invitation, it's there, but you can ignore it until you absolutely. So beyond that, I'm happy to pass the floor to Matthew.
Yeah, thank you very much. Yeah, I got this message that says broadcast message to all for the breakout room. Do I need to click that, or can I just close that window?
You can just close that.
Perfect. Yeah, thank you very much for that introduction. Yeah, it's great to see so many people on here and interested in learning. So what I'll do, so hopefully, you know, that we distributed the some information on getting started and setting up your environment. So hopefully at this point you have RStudio installed and you have it open, and you should see something in front of you that looks like this. There's some instructions here about how to load these packages. So hopefully you followed those instructions and you're able to run this line of code down here without error, but we'll kind of jump into that. So what I'll do, I'm just going to start a new session so we're all kind of looking at the same thing for your first time. So the first time you open up RStudio, you'll see something like this, and we'll kind of talk about this and get comfortable with it as the. So we'll take a look at this. So when you first open up RStudio, someone could just mute themselves there. So the first time you open up RStudio, you'll get some information here about version of R and that. If your version of R is a little bit different, that's fine. My version's a little bit older. But we won't concern ourselves with that too much. So the first thing that we're going to want to do, so if you installed the packages and that, you can run the code down here next to this greater than symbol and this blinking cursor. So you can run all the code that we're talking about down here. But what we're going to do to make things a little bit easier for ourselves is underneath File here, we're going to click this little white page with the green circle with the white cross there and click RScript. So you just want to go ahead and click this. And what that's going to do is open up a new pane at the top here. And this is where we're going to write all the code. So this is RStudio that we're looking at here. And R itself is just a programming language. And there are more programming languages than I can count. There's Python and R and Java and C and C++. And you might have heard of these or not, that's totally fine. But R is a really good language for doing the types of things that we'll be talking about today, which is looking at data, summarizing the data, understanding it, visualizing it, and analyzing it. And there's lots of other things that you can do in R, but those are the things that we'll be talking about today. So we got this tab up, or this pane up here, and we got that just by clicking this little button here and RScript. And this is just a text file here where we can save all our code. And it's as I said, it's the same thing as typing things down here. But the benefit of typing them up here is that you have a file that you can save. So if you do an analysis or you write out all the code that we'll be writing today, then you'll have it and you can refer back to it or run it again. So the first thing that we're going to do is we're going to type library and tidyverse. So what this is doing is it's pulling from our library of installed packages, and it's loading a package called tidyverse. And this is going to be the package that has most of the functions that we use today, and we'll talk about exactly what that means. But unlike running it down here, so if I type this line of code and I click enter, you'll notice that it hasn't run anything or changed our environment in any way. So what we need to do to run this line of code is we need to highlight it, and we need to, just gotta wait for this to exit. So what we need to do is click this run button here. So when you click that, what you're going to see is that down in this bottom pane here, it might take a second. It's going to give us some information that it's attaching packages, and you see a bunch of packages installed here. See some other information. We don't need to worry about that really at this point. And if you run it again, you'll see that it shows you what you've ran, but it doesn't load those packages because they're already loaded. If you see an error saying that it can't find that tidyverse package, you're going to need to run the you're going to need to run this here. So I don't run this if you've already installed the package, but if you need to install the packages, you can do so with this line of code. So the other thing we're going to do is load in a package called Gapminder, which contains the data that we're going to work with. So I'm going to again highlight that whole line and click run here. And when I do that, you see I get a little bit of a warning. It says that this package is built under a more recent version of R or a different version of R that I have. And if you see a message like that, that's totally fine for our purposes. That's not going to cause us any problems. So again, if you have any trouble with following along with what we're doing here, just go ahead and put a message in the chat, and Tyler or John will be able to help you. And we also have breakout rooms that we can deal with those particularly difficult problems. So the first thing that we're going to try running here, and this is going to look a little strange, but we'll just type this out, or you know, we'll even go one step back. So as I mentioned, this tidyverse package has a bunch of code that we'll see what it does briefly, and this Gapminder package, what it has is some data that we're going to work with. And it might not be data that necessarily we're all, you know, personally interested in, but it has the main components that will allow us to kind of look at all the things interesting that you can do in R. And it's a small enough data set that it won't, you know, slow down our computers too much, or we don't need specialized tools to work with it. So there's this data set called Gapminder. And what we're going to do is I've just copied and pasted it here so I can work with it a little bit easier. Whoops. So if you type in Gapminder, and again, if we highlight that line of code and we click run, we'll see that what R does is it prints off the first 10 lines of that data set so we can take a look at it. And this is a general pattern. So if you type in the name of any data set that you have in R, and we'll talk about what that means and how to get your data into R. But if you type the name of the data set, R is going to print off that data set for you. So you see that, again, it reminds us the code that we ran, and then it gives us some information and shows it, you know, some very similar to how it would say in Excel. So it has the name of each of our columns or our variables. So we have a column here for country, for continent, for year, for life expectancy, for population, and for GDP. And then each row of our data we have, so this first row here is from Afghanistan, its continent is Asia, from the year 1952, has the life expectancy in Afghanistan in that year, and so forth. And then there's one other thing that it shows us that is a little bit different compared to Excel or maybe some other programs that you've looked at data in. It has these little alligator brackets here with some information that isn't immediately obvious what it means. But you see here we have FCT, so that's short for factor, or for grouping variable, or for categorical variable, depending on your background. All that means is we just have a variable here or a column of categories, and we see the same thing for continent. For year and population, we have int, which is just short for integer, which are just whole numbers. So year and populations are always in whole numbers. And then for life expectancy and GDP, we have DBL, and that's just computer speak for double, which is just means that we have sort of fractional or decimal numbers. So it's not something typically we have to concern ourselves with, but R is just reminding us sort of the structure, the format of each of these columns. And you see that it says we have 1,704 rows, and it's only showing the first 10, and then shows us that there are 1,694 rows following that. And then it shows us we have 6 columns, and we can see that that checks out. And then the only other sort of strange thing we see here is it says what it's displaying to us here is a tibble. And that's just our speak for essentially a table. We won't get into what that means too much, but for our purposes, we'll just think about this as a table. No different really than data that you'd be used to working with in Excel. So again, by running that line, we get that data set printed there. One other sort of quick trick I'll show is that rather than having to highlight the code and click run, what you can do is if you have your cursor anywhere on that line, including at the end of the line, if you press Control Enter or Command Enter if you're using a Mac, what it will do is run that line of code just the same, and then it jumps your cursor down to the next line so you can type another function or command that we'll look at. So another thing that we can do too if we want to look at our data is we can type in view and then the name of our data. So in this case, it's this Gapminder. So we just have view and then open and close parentheses and Gapminder. And if we run that, so either by highlighting it and clicking run or by just clicking Control Enter, what you'll see is we get this new tab opened up here, just like you'd have tabs in a web browser, and it displays all of the data for us. Again, very similar to how you would in Excel. And we can do things like sort different values or sort different variables and do things like filtering and that sort of thing, like you would in Excel. But for the most part, you don't use this too often when you're working in R. It's kind of just nice to be able to see your data sometimes. So I'll just close that out. We won't really come back to that. So I'll just close this tab here and we'll come back to our code. One other quick thing I'll show that can sometimes cause some trouble is if you're doing the approach where you're running code and you're highlighting it and clicking run, if you accidentally highlight an incomplete line and you go to click run, you'll notice something kind of strange happens. So you'll see down here, it shows what we ran, and we can see that we forgot to include that closing parentheses. But we don't get any sort of error message or anything like that. We just get this plus here. And if you hit enter or do anything like that, it doesn't seem to want to escape or let you run other things. But all that means is that R is just waiting for you to sort of complete that thought. So if you want to, you can highlight that little bit of code that you forgot to run and click run, and R will complete that for you. Or if you, run that incomplete line, if you click down here and just press escape once or twice, it will just clear that console down here for you so that you can run other functions or whatever it is. So that's something that can sometimes just trip you up and cause some grief if you're not used to it. So this is very basic so far. So we've just loaded some packages, which is just code or data, and we've looked at the data. But now what we want to do is look at actually analyzing this data set and getting some understanding of it and doing some analyses and visualizations and that sort of thing. So you'll notice here that we've run some similar looking things. So we've run view, and in parentheses we have Gapminder. We've also run this function called library Gapminder, and this is going to be the main form of things that you run in R. So if you've used any other programming language or you've used Excel, this type of thing will be familiar to you, where you have the name of a function that you want to use. So you're either viewing data, or you're installing a package, or you're loading a library or a package, and then you follow that with parentheses, and then one or more pieces of information. And in this case, it's a data set. But we'll see how we kind of use this pattern over and over to do things that are interesting. So let's remind ourselves what we're looking at here with this data set. So if we want to start to understand this data set, one of the first things we might want to do is to know how often each of these continents appear. So we see that Asia's here, but we want to know what other continents there are and how often they appear out of these 1,700 plus rows. So what we're going to do is I'll just type this out, and I encourage you to type it out as well, and we'll talk about it. So I've written Gapminder, and then here I have a % sign with a greater than symbol and another % sign. And then I have this function here that's count and then continent inside. So what we'll do is we'll just run this. and we'll see what this gives us. And then we'll talk about how we make sense of this and what this means. So I'll click run. And what we see here again, so R has shown us the line of code that we've ran here, and then it gives us some information. So again, it tells us we have a table, tells us we have 5 rows and 2 columns, tells us we have 1 column that's continent and 1 that's N, and we have each of our continents and each of our, the number of times that each one of these continents has appeared. So Africa appears 624 times, the Americas have appeared 300 in our data set, and so on. So what we have here is a function that counts up any sort of variable that we want. It tells us how many times each thing in that column or that variable appears. So that's what it does, but now we want to kind of make sense of this and, how did I know to type in this sort of strange looking thing? So, even though it looks strange, once we sort of wrap our heads around what this is, we'll see that this is a very powerful sort of approach, and we'll be able to do lots of interesting things once we start to make sense of this. So what we started off here with is the name of our data set. And if we're using a different data set, it would be a different name. And we'll talk about that in a bit. But we're using this data set called Gapminder. And again, we could always just run this one part of the code to remind ourselves what that is. It's just a data set. And then what we wrote here is something in R that we call a pipe. So it's a little bit of a strange symbol, but what this pipe does is take whatever's on the left-hand side of it and then pass it to the function on the right-hand side of it. So on the right-hand side, we have this function that says count continent, but by itself, this doesn't make a lot of sense because R doesn't know what continent refers to. It doesn't know what data set it refers to. So that whole line here sort of solves that problem. It's saying take this data set called Gapminder, and we can read this pipe as kind of saying then. So we want to take Gapminder, and then we're going to pass it to a function that's going to count continent. And by doing that, R knows that this continent is coming from the data set called Gapminder. If we wanted to count country, then we would have switched out and had country here rather than continent. So it's a little bit strange, and there's no way you could have known that that's how you would program in R before you got started. But once you kind of get used to this idea, it'll become second nature, and we'll see how we can do lots of interesting things with this fairly basic idea of starting with a data set, piping that or passing that to a function that does something interesting that we want. So I'll copy this and we'll see how we can vary this just a little bit. So again, as I said, if we wanted to count the country rather than continent, we could just switch out country here, and I'll run that. And we see that we get a count of how often each of the countries appears, and each one appears 12 times. We could also switch that out for the year if we wanted, and we can see how often each of the years appears in our data set. And you can also count combinations of things. So if, for example, we want to count how often each continent and year appear in combination with each other, we can say count the continent and then a comma, and year. And if we run that, we'll see that we get the same idea out as before, but what we get is now we know that Africa in the year 1952 appears 52 times in our data, and so on. So this is really helpful when you're working with data. You need to know how often each thing appears. And this isn't super interesting right now, but we'll see how we can use these ideas to do some interesting things right away. And you can separate whatever columns in your data you want by commas like this. So if I wanted to also include country in this, I could do so like that. And we'll see how often each continent and year and country appear. And we can see that each of them just appears once. Another thing that you might need to do is, I'll go back from this initial line of code. So we'll notice that when we run this here, we get our counts of how often each of these continents occur, but it's not in any particular order. So we'll see that the largest is here, and then the third largest or the second largest is here. But if you want to have this in order, which sometimes you do, especially when you have a lot of categories, it's useful to see that in an ordered way. What we can do is we can put a comma again, and we can give this function this optional in programming what they call an argument or a parameter, but really it's just an optional way of getting this function to work. So if we type in sort equals true, and true has to be in all capital letters. And we can see that it gets highlighted there, indicating that it's sort of a special word in R. If we run that, we'll see that the function behaves the same way, but we just get this optional behavior where it's ordered our output from largest to smallest, which is helpful when, again, you have a lot of categories. And one of the things you might start to wonder is, well, how did I know that this was an option, that you can do sort equals true? Or, what other options are available to get this function count to work? And the way that you can do that is if you type in a question mark and then any name of the function that you want to see how it works, and you run that just like you do any other function, you'll see that on the right-hand side here, it brings up a help page. So it says, count observations by group, and it says, this count function lets you quickly count unique values of one or more variables. And then it gives a bunch of information. But down here, we'll see that it gives us information on optional arguments that you can use to get this function to work. So it tells you that there's a sorting option, there's a naming option. So if you want this to be a different name other than N, you can do that. There's an option for weighting and so forth. If you scroll right down to the bottom, they give you lots of examples so you can kind of work through and understand how to use this function or what options are available to you. So that can be helpful. And realistically too, sometimes these help pages can be a little bit dense. Usually Googling it and saying, the count function in R, you'll see lots of pages that help you understand how that works or different options that are available to you. And again, this idea of using the question mark with the name of the function will work for any function in R, and it'll bring up this help page for you. So we've looked at counting, so that's a good way to understand data when you have categories. But when you have, something like life expectancy here, whereas we could count and see how many times each of these values appear. So we could say, well, how many times does 28.8 appear? That's probably not going to get us very far or be helpful because each one of these values is so unique. It's probably only going to appear one time. What we want to do is maybe get something like the average life expectancy of our data. And the good thing is everything that we've talked about so far, we can use kind of the same ideas. So what I'll do here is we'll just type this out and then we'll talk about it. So I'm starting off the same way with the name of the data set. I'm using this pipe again, but rather than using the count function, what I'm going to use is a function called summarize. And this is for summarizing your data and more when you're summarizing numbers like we have in these columns here. So what I'm going to do here is type this. This won't actually work yet. So if you run it, you won't get anything helpful. But we can see that the pattern is the exact same as what we had before, right? So we have our Gapminder data set, and we have this pipe, which we'll read as then. So we have our Gapminder data set, and then we're going to summarize life expectancy. Now, again, this by itself isn't going to help us because what we have to do is tell R in what way do we want to summarize life expectancy. There's a lot of different ways we could do it. We could get the average, or we could say what's the minimum life expectancy or what's the maximum. And there's lots of other ways we could summarize that. So what we're going to do is we're going to get the average life expectancy, or the mean, as they say in statistics. So here, we'll write this out. So what we have here is sort of a function and a function, which gets a little hard to think about, but we'll talk about this. So what we have here is the mean life expectancy, and we have that inside this summarize function. So what we'll do is we'll just run this, and we'll see that we get out the similar type of output as we've had before. So it tells us we have a table, it just has one row and one column. It reminds us of what this summary is, which is the mean life expectancy. And then it gives us the average life expectancy for our data. So now we know in that column, the average life expectancy is 59.5. And the nice thing is that we can copy this line of code here and switch out any function that we want for summarizing this life expectancy. So we could change this to min, which is the minimum. So if we run this, we'll see that the minimum life expectancy in this data set was 23.6. We could also change this out for max, which gives us the maximum, which in this case is 82.6. And you can change out any function that you want to get a sense of how that variable to summarize that variable essentially. Now you might wonder, well, what functions are available? Like, how did I know this was max and not maximum or mean? That's something that you just learn as you keep working with R. Again, you can kind of Google these things or always get the help page by typing in this question mark and max. And if I do that, you'll see that it tells you that min and max calculate the minimum and maximum. But I'll just tell you about the most common functions that you might want to use. So there's the mean, there's median, there's min, there's max, there's the sum. So if you wanted to get the total sum of a variable, in this case, life expectancy, that wouldn't make much sense, but you could. And then there's also things like, if you're familiar with statistics, things like the standard deviation or the variance. And if you're not familiar with those, that's totally fine. But these are common functions that you'll use to summarize a numeric variable or column in your data. And if you've worked with data, this is something that you're very familiar with. Now, the one thing I'll say is you'll notice that before I wrote all of these, I put a comment or a hashtag there. And what that does in R is that tells R to treat all of this not as code, but as just something that you've written. So you'll see that if we run this here, R will print that, but it doesn't try to interpret that as code. Whereas if I just ran something like mean, R is going to give me something strange because it's trying to interpret what I'm doing as code rather than something that's just for my own personal consumption or use. So using comments is something that's really helpful to leave comments to yourself, to remind yourself what you've done, or to remind your collaborators what you've done. And again, R won't treat this as code, just treats this as a comment. Whereas if I had something like this just written and I run this, R is going to complain because it thinks that what I have here is some sort of function and it doesn't know how to interpret it. So we've seen how we can summarize our variables like this, which is really helpful. But there's a couple things we can do to make this even better for ourselves. So we'll see that here we copied and pasted both lines of code, and the only thing we really switched out is this mean and this max, which is a lot of copying and pasting. And it's kind of error prone and tedious. So what we can do is we can make this a little easier for ourselves. And what we'll do is we'll put a comma after this max life expectancy, and then we can have other types of functions. So if I say I want median life expectancy, we'll see that when we run this, R gives us each of these in the same output, which is more helpful than having to run each of these functions separately. So it just kind of bundles it all up together. And again, we see we have one rows with two columns, and we have the maximum life expectancy and then the median life expectancy. So we could include as many of these as we want, and it doesn't have to be the same variable. So for instance, we're doing this with life expectancy, but we could say, what is the minimum year? Because year is a variable or a column in our data set. And if we run that, now we see we have 3 columns here. So we have the max life expectancy, the median life expectancy, and the minimum year. And the one other thing we can do to kind of make this a little bit easier for ourselves to read, we see that this line is starting to get kind of long. And if you write a really long line of code, then you have to kind of go and scroll. So the nice thing is we can start to separate this out onto different lines. So I'm just going to put this summarize function on a different line. And I'm also going to put each of these on a different line here. And we'll see that if we highlight all of that code and click run, it runs the same way. So similar to when we're writing out, something in English, for the most part, the spaces don't contribute a lot to its meaning. The meaning isn't so much in the spaces between, but the words that we write and the paragraphs and that sort of thing. And the same is true with R. So you can put really any sort of spaces in that. There are some exceptions, but you'll see that this makes it a lot easier to read and to keep track of what's going on. So, and again, the way we read this is we have the Gapminder data set, and then we're summarizing that data set, and we're specifically calculating the mean, the median, and the minimum of each of these variables. So that makes your code a little bit easier to read and to write, and it prevents it from kind of running off the screen. Now, the one thing we can do to make this even a little bit easier to read, we see that here we have these columns that aren't the nicest to look at, right? Like they say max and then kind of remind us of the function we use. But what we can do is change this so that we have our own names in here. So what I'm going to do is right here, type this in. So I put a name here that says max underscore life underscore expectancy. You could make this any name you want. This is just what I've chosen. But for the most part, you can't have spaces and that sort of thing, or other sort of symbols like dollar signs and that. But if we put a name and then an equal sign, what R is going to do is to give this the name that we assign. So if we run that, we can see what we're looking at here. And sure enough, we see that we have this variable name rather than these given names. And we could do that with each of these. So I'll just do it with this next one here. So if I do that and run this, we'll see that we have these names we've given it, which is nice if you're sharing this with someone or just to make this a little bit easier on the eyes to read. So we've seen how we can count variables when we have categories. We've seen how we can do summaries on numeric variables, which is really helpful and something that you typically do in every analysis. But the next thing we'll kind of look at is this issue where we have our data set. So let's just look and remind ourselves. So we have the Gapminder data set, but typically, and maybe this is the case here, we have more data than we might actually want to use. So for example, we see we have a lot of old data here. We have data from the 50s and the 60s, but it might be the case that we don't actually want to analyze all of this data. We might want to get rid of some of it. So for example, we might only want to look at data that is from the year 2000 and later. So to do that, what we're going to do is we'll start off the same way. So we start off Gapminder, we'll write the pipe, but then we'll use a new verb or a new function. So rather than using the count function or the summarize function, what we're going to do here, I'll just press enter to start it on a new line, is we'll use this verb or this function called filter. And what that does, as the name suggests, is allow you to filter your data or subset your data in a way so that you only access or use certain parts of it. So what I'll do here is, we'll talk about this, but I'll type year greater than 2000. And what this is going to do is filter the data so that it only uses the data that's greater than the year 2000. And if we run this, we'll see that sure enough, we have a smaller subset of our data now. Rather than 1700 rows, we only have about 280. And we see, sure enough, that all of the values in year are greater than year 2000. So this is really helpful anytime you're analyzing data, because you might not want to analyze all your data. You might want to analyze only a particular group or from a particular year or people who scored higher than a particular score. So this is really helpful. And the nice thing that we can do too is we can start to combine these different ideas we've seen together. We can pipe this data set here that we have that's filtered right into a function like count or summarize. So I can use the pipe again, and I can say count continent, for example, and we can run these 3 lines of code, and we can see that now what we've done is we've started with the Gapminder data set, and then we filtered to where year is larger than 2000, and then we want to count the continent. And again, now we're counting based on this filtered data set because we've piped in what came before it, which was this filtered data set. So you can see that using these pipes where, at the beginning it might have seemed like, it was kind of excessive and the usefulness of it wasn't readily apparent. But we can use these ideas, these functions together with the pipes to do lots of interesting things. And we'll see how pretty soon we start chaining a lot of these functions together to do a more realistic analysis that's a lot more interesting. So you'll notice here that I filtered this year by using the greater than symbol, but there's lots of other what they call relational operators that you can use. So we've looked at greater than, but you can also do greater than or equals. You can do less than. You can do less than or equals. And then if you wanted to do equals, it might be tempting to think that that's just the equal sign. But in most most programming languages, and R is no exception, you need to use two equal signs. Oops, two equal signs. And what that's doing is testing for equality. So for example, if I want to filter out only the data that's from the year 2002, I would do it this way. So I have year, and this is checking to make sure it's equal to the year 2002. And the reason you need to use two equal signs is really just to differentiate it from when we're doing things like naming, where we're just using one equal sign. So for the most part, when you see one equal sign, that typically has to do with naming, or like when we used an optional parameter here for a function. And when we use two equal signs like this, that's to test for equality. So it's checking that the year is equal to the year 2002. And then the last, what they call relational operator that you might use is if you want to check that the data is not equal to something. And in that, you use the exclamation point and then it equals. And this is, again, pretty familiar if you've done any programming, but if not, that's fine. But typically an exclamation point in programming is means not. So we have not equal. So if we wanted to change this a little bit so that we had all the data except data that was from the year 2002, we would use the exclamation point and equal, and that will only give us data that is not from the year 2002. And you'll notice here too, you can highlight just parts of the code. So even though we've written this longer expression with multiple pipes, I can just run individual bits of code or highlight just the parts of code I want to run, which is really useful for trying to figure out how code is working. You can run each line separately and sort of see how one step leads to the other. So this filtering step here works too with categories. So we've used it for numbers for filtering the year. But if we wanted to do something like, say, we want to filter where the continent is equal to Asia, we can do that here. So we have continent, again, we have two equal signs, and then we have Asia. And we need to put Asia in quotes like this because it's not a variable or a column of our data set. It's an actual value. So if we run this, we'll see that now our data set only has data from Asia. Again, we can see that data set's a lot smaller. So again, this is really useful. Sometimes you want to analyze, if you're doing an experiment, only analyze data from a particular condition or a group, or you might want to only analyze data from a particular city or from a particular year. So by using these filters, that allows you to do that. And the nice thing is we can use these filters, use multiple of them, just like we use the count function after. We can use the filter function again. So if I wanted to say something like this, what we have is we have Gapminder, and then we filter to where continent is equal to Asia, and then we filter where year is greater than 2000. So you can apply multiple filters to get the data down to the subset that you want. So again, that's something that's very common and very useful. So when we ran this, we'll notice that we only get data where both of these conditions are true, where continent is equal to Asia and where the data is from greater than 2000. But sometimes you don't want both conditions to be true, or in other words, you might be okay with either or of these things happening. So maybe you're okay with using data that's from Asia or data that's from 2000, but it doesn't have to necessarily be both of these things. So we can alter the way we've been working with these filters a little bit and see how we can do something like that. So the first thing we'll do is we'll rewrite this in a slightly different way, and then we'll see how we can expand this to do what I said there, where we want to check if only one of these conditions is true rather than both. So we'll just quickly write this out and then we'll talk about it. So again, we'll start off in the familiar way. Continent equals, and then I'll write an and. So, as I said, it looks familiar, but it's a little bit different. So we have Gapminder, and then we're filtering. And we have this part here, which is familiar from up here. And we have this test here, which is familiar here. But what we've done, instead of writing two separate filter functions, what we've done is separated them with this ampersand. And what that does in programming is checks to make sure both of these conditions are true. So it's going to filter only, it's going to return only the data where the continent is equal to Asia and the year is larger than 2000. So this right here is identical to these lines of code here. And it would really just be a matter of preference, which one you used. But the nice approach to doing this is if you determined that you didn't actually want both of these conditions to be true, but you only wanted one or the other to be true for the data to be used, all we have to do is change this symbol from an ampersand to this vertical bar here. And you get that by, it's right above the enter key on most keyboards. There's the backslash, and then if you push shift and backslash, you'll get this vertical bar here. And what this is computer speak for or. So the ampersand is and this is or. So when you have an or in the filter, what it's going to do is return data that where either one of these two conditions is true. So if we run this, we'll see we have data from Asia, but if we looked further down the data, we would see that we would also have data that wasn't necessarily from Asia, but was from the year 2001 or later. So again, by combining these different ideas, it lets you, it allows you to filter or to subset your data down to the parts that you actually want to use. And we can take this idea, if we wanted to, for example, only include where the continent is from Asia, or say Africa, we can do that by doing this. So we can say continent equals Asia, or where the continent is equal to Africa. And again, oops, sorry, I just wrote that. So again, we have Gapminder, and then we're filtering to where the continent is equal to Asia, or where the continent is equal to Africa. So again, that allows you to combine these different ideas to filter the data in any way you want. But you can imagine if you maybe had, if you wanted to include more continents, this would start to get a bit long to include another or, and then say, continent equals the Americas. You can see now it's starting to run off the screen, starting to get long to type out. It's error prone and tedious. And especially when you have a lot of groups, if you had 10 groups, this would start to get really, really long. So luckily R lets us do this in a bit more of a slick way. So again, we'll just write this out. We'll take a look at it. So we're starting off the exact same way, Gapminder filter. And this will look a little strange. There'll be some new things here, but we'll talk about this in a second. So we have some new things here. So the Gapminder is familiar, the pipe is familiar, we have filter, and now we have continent, but we're using this new function here that's the percent signs around in. And what that's going to do is essentially what we had up here. It's going to check to see if continent is in this list of items, which is Asia and Africa. And we could include other ones here. So if we wanted to include Americas, we could do that as well. And this these two lines of code here are identical to these two lines, but you can see that this is a lot more readable and easier to adjust. And we also have something new here where we see that we're using this function here that's just a C. And what the C stands for is combine or concatenate. So basically just taking whatever things that we put inside this function and sort of sticking them together. So we're just taking Asia and Africa and Americas, and we're sticking that together in one list or one vector so that R knows all of those things belong together. And if we run this little bit here, we can see that it's nothing too exciting. It's just take these three items and sort of stack them together. So this is really useful when you want to check to see if a variable or to filter a variable so that it's in a list of items like this or a vector of items. And the nice thing, again, if we wanted to include more here, we could do that just by, oops, just by adding on to our list there. So the last thing I'll talk about with filtering is, for this example here, where we filtered for the year greater than 2000, we've used a number to do our filtering that we sort of hard-coded ourselves, but we can use the statistical functions that we talked about, like mean or max or median or any of those, to filter as well. So if we have Gapminder, we can say, for example, filter where life expectancy is greater than the mean or the average life expectancy. So, it looks a little bit more confusing, but it's the same idea here, where all of this is really a number that's calculating that average life expectancy. I think it was 56. So all that's doing is filtering out, and it's only going to present the data to us where the life expectancy is greater than whatever that value is. So if we run that, we see that our life expectancies are a lot higher because they're only included in the ones that were greater than average. We have a smaller number of rows as well. So we've looked at counting, we've looked at summarizing, we've looked at filtering. The next sort of verb or function that we want to use is to actually make changes to our data set. So for example, if we have Gapminder, we might want to do something where we want to change the life expectancy in some way. So maybe we need to subtract a year off each life expectancy for some reason. To do that, we're going to use this verb called mutate, which is just for changing variables. So we'll say life expectancy and say -2. And what that's going to do is take our data and it's just going to subtract 2 off each value. Now, in this example, it's not really realistic why we'd want to do that, but you could imagine something where if you had an age variable or an age column in your data, and the data set was, a year out of date, you might want to add a year to everyone's age so that the data is updated or something like that. But we see that when we run this data here, or run this function here, what we get is we get 2 subtracted off of each of these values. So we actually see we get a new variable on our data set here. It's reminded us what we've done. We've subtracted 2, and it's just gone and subtracted 2 off of each one of those values. So this allows you to change or to mutate the variables in your data set in any way that you want. And again, we could change this out for a function like the average or something like that in any way that we want. And again, we'll notice that here we get a reminder of what we've done and a new variable attached to our data set. But if we wanted to, we could sort of copy over that variable, so to speak, by including the variable we want this to be saved to. And in this case, it's life expectancy. So if we run this, what we're going to do is we're going to see that our life expectancy variable is now kind of, copied over or mutated to subtract 2 off of each of those values. So again, this is something that you'll do all the time because typically you'll need to do some sort of mutating or changing of your data set to get your data in the shape that you need it to be in. I'll show you 2 quick more functions that you'll typically want to use, and then we'll see how we can start to apply these things together, and we'll see how we can start to visualize the data set. So we'll start off with the Gapminder data set again. Sometimes when you have a lot of variables or columns in your data set, you don't necessarily want to use all of them. They'll start to fill up your window here, and it gets a little bit hard to read. So what we can do is use the verb or the function select, and we can just select the variables we want. So for example, if we only want country, we'll just get the variable country here. If we want to include another one, we'll use the same idea where we separate this by a comma. So if we only want country and year, we get that. And if we want all the variables in the data set except for one variable, what we can do is use the exclamation point, which is, again, computer speak or programming speak for not. So we're selecting not country or everything but country. And if we do that, we see, sure enough, we get all the data back except for that country variable. Another thing that you might want to do is you'll notice that these values in here aren't organized in any particular way. They're just organized according to how the data was made. So another function that you'll typically use a lot is this function called arrange. And what that does is just sorts or arranges your data set according to a variable. So if I say arrange life expectancy, we'll see that what we get now is our data set arranged by life expectancy from smallest to largest. And again, we can use multiple variables. So if we first want to arrange by life expectancy and then by year after that, we can do that like this, just separating the variables with commas, and we can include as many variables in there as we want. And again, this is helpful if you're sharing data with someone or a smaller table. Sometimes you want it arranged in a particular way rather than just being in a more haphazard fashion. And so by default, this will arrange it in ascending order. But if you want to do this in descending order, what we do here, I'll just get rid of this and just do this with one variable. We need to have another function inside there that's descending, short for descending, and it'll arrange that then by largest to smallest rather than smallest to largest as it does by default. So we see that we have the largest life expectancies up at the top. So that's essentially it for these main sort of verbs that you'll use in 95% of cases. You'll either be counting or summarizing or filtering or arranging or selecting. That gets you a very good distance. But you'll notice that everything we've done so far has been at the level of the entire data set. So typically you might not be interested in just the life expectancy of the data set as a whole, but you want to do it within particular groups. So for example, you might want the average life expectancy by particular continents. So the nice thing is that by using these functions that we've talked about, we can just include one extra trick in there, and that will allow us to do everything that we've done so far, but by groups. So let's just remind ourselves here. So let's go with Gapminder. Let's say we want to summarize and get the average life expectancy. So we all know what this is now. Just returns the average life expectancy for the whole data set. But if we want to do this for each group, say for each continent, the nice thing is all we have to do is add one more function in between these two. That's called group by, so group underscore by. I don't know why that's there. Group by, and then we can put in the variable that we want to group by, and then a pipe. So what this is going to do is it's going to take the Gapminder data set, and then it's going to group it by continent, and then it's going to summarize it in the exact same way. So if we run this, we see that now rather than just getting an average life expectancy overall, we get an average life expectancy for each continent individually. I'm not sure if anyone else can see this line on there, but if there's a way to get rid of that, that'd be good. So the nice thing about this group by function is that, again, it allows you to use all the tricks and all the verbs or functions that we've used before, but to do it by group. And this function itself is not doing anything particularly special or complicated. If we run this, what we'll see is seemingly it does nothing. It just prints off our data set, but we'll see that behind the scenes, what R has done is grouped this data set by continent, and it's reminded us that there's 5 groups. So anything we do after this group by function, so any summarizing or counting or filtering, everything will be done at the level of the group rather than for the whole data set. And again, this is incredibly helpful. It allows you to combine these different verbs in ways that are, solve 95% of your data analysis and data wrangling issues. So as I said, everything that you do after this group by function will be done at the level of the group. So to turn that sort of grouping behavior off, what you'll do is, we'll just use another pipe, and then what you do is use the function ungroup. and that will turn this grouping behavior off. So anything that you do after that, that ungroup function will no longer be at the level of the group, and it will just be for the data set as a whole. So now we'll get into the plotting aspect, the visualization, and we'll see how when using the same ideas in just a couple of lines of code, we can make really cool and beautiful plots in R really easily. But the last thing I'll just touch on is that you'll notice that as we've been using all these functions, the underlying data that we've been looking at hasn't changed. So if we look back at the Gapminder data set, even though we've done some grouping and some filtering and everything, when we type in Gapminder, we have the same data set as we started off with. It has these 1,704 rows and 6 columns. None of the things we've done have modified that original data set in any way. And sometimes you want to modify the data set so you can use it. So let's take a quick example here, and I'll show you how you can do something that is useful. So we'll type this out. We'll just talk about it here. So you see that we have this part here, which is familiar to us now. We have Gapminder and then our filtering operation. So if we run this by ourselves, we all know what that does. It returns the data set that's filtered. But when we look back at Gapminder, we see that it itself hasn't changed in any way. So to change the data set, or to sort of save a new object or a new data set, what we need to do is use this thing in R called an assignment operator. And it looks like a little arrow. It's just the less than symbol and the hyphen. And what that's going to do is take whatever's on the right side of that, so all of this code, and it's going to stick that in a variable name or an object or as a data set, and it's going to save that as the name you give it. So I just made this name here, Gapminder_filter, but you can make the name anything you want. And when we run this line of code, we'll see something a little bit different happens. So down here, we just got reminded of what we ran, but we don't get any output down here. But if we look at the top right corner here under this environment tab, we'll see that we have a new object, and it says Gapminder filter, and it tells us that we have 284 rows and 6 observations. So what we can do is if we click this, we'll see that we have this data set that we filtered called Gapminder filtered. And the nice thing is we can use this new data set just as we would any other data set, or just like we would have used the Gapminder data set originally. So if I take this Gapminder data set or Gapminder filter and say, count continent, what it's going to do is it's going to count the continent, but from this different data set that we have here. So if I run that, we'll see that the results differ a little bit from when we had the original Gapminder data set. And this is really useful for sort of saving intermediate steps, or if you've done a bunch of filtering operations and summarizing and arranging and that sort of thing, and you don't want to have to re-include that for all of your code every time you do something else, you can save that output or save that object or that data set as sort of an intermediate step. So, if this filtering step was going to be done for everything that followed, you can save it as an intermediate step here called Gapminder_filtered or whatever was appropriate, and then use that new data set the same way you would any other data set, which again is really helpful. And as you start working with more data sets and you start to modify these data sets in different ways, you'll start to have lots of different objects or lots of different data sets in here that you might be working with. So it's something that is very common. So now what we'll do is look at plotting in R, and we'll be using a package called ggplot2, and that's loaded in this tidyverse set of packages. So what we'll do is we'll kind of continue with the same idea. We'll just write it out, we'll see what happens, and then we'll talk about it. So the good thing is we'll start off the exact same way. We're just using the Gapminder data set, but you could use this Gapminder filtered if you wanted to. So we'll start with Gapminder, and then we'll just type this out and talk about it. So I have Gapminder, the pipe, and then I have this function called ggplot. And then inside of that, I have another function. We'll talk about this because this is all going to look very unfamiliar. I have another function that's AES. And then rather than the pipe, I have a plus. And then I have another function that is geombar. And we'll see that there's nothing actually inside of that function. So this looks probably a little bit familiar, but it's going to be a little bit strange, and we haven't seen this exactly. But if we run all of this, we'll see that, again, R reminds us of what we printed. But now what we get in our bottom right-hand side in this plots tab is a plot. So what we have here is we have each one of our continents, and then we have a count of how many times each of these continents occurred. So this is the same information as when we use that count function, but just displayed in a visual way. So Africa appears 600 times, the Americas appear about 300, and so on. So you can see that in very few lines of code, we have a nice looking plot. We'll talk about how to tweak this in a bit, but we see that we have a really good plot that gives us the information that we want, shows us how often each one of these continents appear. So now let's try to understand what's going on with this code. So we have Gapminder, we know that. We have this pipe, but now we're using this function called ggplot, which you'll use for every type of plot that you want to make using ggplot. And then inside of that, we have this function that's hard to know what it does exactly, but it's AES. And that's just short for aesthetics. And all that's essentially doing is figuring out what variables you want on your x-axis or your horizontal part of the graph or the y-axis. So in this case, we've just given it one variable. So that's going to be for our x-axis or our horizontal axis. And we haven't given it any other information. And that's okay for this plot. We'll see how we can start to give it more information. So again, if we run just this first part, we can see what this is doing. So all of this ggplot function really does is just set up the basic plot. So it puts down the variable that we want on the x-axis and sort of sets all this up, but it doesn't plot any sort of dots or points or lines or text or anything in the main plot. That's the job of the functions that sort of follow. So this geombar function will draw bars on the plot based on the information we gave here. So it's going to put a bar plot for continent. So when we run all of that, we see that it does exactly that. It draws these bars on there and adds the appropriate y-axis. And then the last thing that maybe looks a little bit unfamiliar before we start seeing how we can use this basic idea to build any type of plot we want really quickly is we notice that we have a plus here rather than a pipe. Which is a little bit strange, but you use this plus when you're doing plotting in ggplot. And the only real reason we use that rather than the pipe, even though you can think of the pipe and this plus is the same as the pipe, is because when you're doing plotting, you can kind of think of it as adding a layer of plots on. So we'll see that just like with the pipe where you can use multiple pipes, you can see how we can start to use the plus to add on different layers of a plot. It's sort of almost like a printing idea where you add layers on top. So let's see how we can copy and paste this and just change out two quick things and get a completely different type of plot. So we'll keep the data the same. Everything here will stay the same. But what we'll do is rather than continent, we'll have life expectancy. And because we're putting this first, that's going to be on the x-axis. And then we have a comma, and then we'll put GDP per capita. And you'll notice in R, as you start to type things out, R will be helpful and bring up these little pop-up windows for you. So once I typed in GDP, GDP per capita comes up. So I can just hit enter and it'll auto-complete that for me. And the only other thing we'll switch out is rather than a bar, so rather than geometry, that's a bar, what we want is a point. So this is going to make a scatter plot, if you're familiar with that. So if we run this, we see that we get a scatter plot. So we have life expectancy on the x-axis, we have GDP on the y, and the reason why R knew to put those in that order is because of the order we gave it here. Had we switched these two around, they'd also switch on here. And what it's done is it's gone and drawn a point rather than a bar for each row in our data set. So again, if you're familiar with data analysis and these types of plot, this will be very familiar to you. But we can make lots of different types of plots by just switching out a few of these the way we did with this last example. So if we want to, instead of a bar plot or a scatter plot, what we can do is get a histogram. So we can get that out of for life expectancy. So if we type in genome histogram, all we have to do is change that. And now we have a histogram showing how often these different ranges of life expectancy occur. So very small life expectancies occur infrequently. Life expectancies around 7 occur often in the data set. So again, if you're familiar with statistics and data analysis, this will be something that's very familiar to you. But we can do lots of other types of plots. So for example, I won't show them all here, and I'll show you how to find out about them. But if we wanted to do something like, say, for a continent, life expectancy on the x-axis, if we wanted a box plot. Oops, check that wrong. If you're familiar with box plots, you can get that very easily. So it shows the range or the distribution of each of life expectancy for each one of these continents. And if you're not familiar with the box plot, that's okay. But the nice thing is that just by switching out X and the Y variables for this basic pattern and switching out the type of geometry that you want to include in the plot, you can really make any types of plots that you want. And you can also start to stack these different pieces of geometry on top of one another. So if I wanted to, for whatever reason, I could add points on top of this. So it's going to draw a box plot, and then it's going to draw a scatter plot on top of that. So now we see that we have the box plots, and then it's put the points. And of course, all of them are just falling on a line. But you can start to include these different geometries or these different points in ways that are interesting. And I'll show you a more realistic example here. So let's say that we have this scatter plot. So we have Gapminder on the x-axis, we have life expectancy, we have the y-axis on the GDP on the y-axis. So we get a scatter plot here. If I want to include a line that sort of shows the trend of this data, we can add a plus, and then we can say geom smooth, which is just going to be a smoothed line. So if I add that, you see that we get the scatter plot as well as the line that shows the trend or the pattern of this data. And you can include as many of these as you want. And the way to kind of find out about which ones are available is if you type in geom underscore, you'll see that R brings up this helpful little pop-up here where it'll show all the different types of plots you can make. So you can make area plots and bar plots, you can make contour plots, curves, density plots, goes on and on. So you can look into this and see what types of things you can do, or you can just Google it to make the type of plot that you're after. But a scatter plot and bar plots are the ones that you'll most typically come across. So I'll show you a couple of quick things with plotting that are really cool and really useful. So we'll kind of just go off this basic scatter plot that we've been working off here, but we'll add a couple things to it. So for example, maybe what you want to do is, what would be nice is to color code each one of these points by continent, so we can see how the continents are distributed across this plot. So what we can do here is we've given the variable we want on the x-axis and then the y-axis. But what we can do is add one more optional piece of information and say we want to color by continent. And now when we run this, we'll see that R is color-coded each of these points by continent. So we see that this big cluster of points here are from Europe with high life expectancy and, you know, sort of a higher GDP, though not the highest. So that's something that's really helpful. And you'll notice that R is, you know, very user-friendly and helpful in the sense that it's given you a legend. That's not something you have to specify by yourself. It does that all for you, which is nice. And there are ways to turn this off or to modify it, but those are things that you can look into yourself. They're quite easy to do. Another thing that you might want to do is to size each one of these points by a third variable. So rather than color, what we'll do is we'll say size by population. So that's the variable pop in the data set. And we'll see that now each one of these points is sized by the population. And it can be a little bit hard to see because some of these points are hidden in there, but you can see that this point here specifically has a large population. And again, R is helpful and kind of gives you this legend, but there's ways of customizing and modifying all of this to make it a little bit more easy on the eyes and more presentable. So I'll show you two more quick tricks with plotting. So one of the things you'll notice is that R gives you these axis labels here, but they're just the names of the variables that you specified. And you might want to put a more user-friendly name in there. So to do that, we'll just stick with this here. We can add on another function, and this is called labs, short for labels. So what we can do is we can say we want the X label to be, it can be anything we want, but life expectancy, oops. So life expectancy. And we'll see that that changes the X label there. We can also put another comma and say we want the Y to be GDP, and that changes that as well. And we can also do things like add a title by saying title equals whatever it is, and R will put title in there, and I'll just start putting these on an extra line so it's a little easier to read. And then we can also change the labels for these different aesthetics or these different features of the plot, like size or color. So if I say, I want size to be population, we'll see that that changes the label that arrives here. And if it was color, then you could do that with color as well. So it allows you to easily customize the plot to make it a little bit more readable for people, to make it a little bit more professional. Now, the last thing in plotting that I'll show you is analogous to this idea of grouping. So we looked at how you could calculate an average for the whole data set, but if you want to do that for every group, you just need to use this group by. So you might want to do a similar thing with plotting. You might want to have a scatter plot, not for the entire data set as a whole, but for, say, each continent. So in some sense, we already know how we could do that. So I'll just copy this up here so we have it. So what we could do is we could write a filter statement in between here and say, I want to filter continent only for Asia, and then pipe this to the plotting function. So we could do that. And now we have a scatter plot that's specific to Asia. And we could copy and paste this, 4 other times, one for Europe and one for the Americas and so on. But again, that's a lot of copying and pasting. And it's error prone and it's tedious, and luckily R makes our life easier. So we can just get rid of this filter statement. And what we're going to do is stick with the same idea here that just makes a scatter plot. But what we're going to do is add on this one other function, has maybe a little strange name, but it's facet wrap. And in plotting, faceting or latticing is when you make a plot multiple times by different groups. So this is just going to say, listen, whatever variable I give you here, make the same plot by all these different groups. So to do this, you just have to write this. It's called a tilde, and that's right above the tab button on the keyboard on the left-hand side there under the escape key. And that's typically, statistical speak for as a function of or by. So it's saying, facet this plot by continent, or in other words, make this plot for each continent. And we'll see that when we run this here, we get out the scatter plots, but now it's for each of our continents individually. And again, this is incredibly nice. If you have 20 different cities of data that you're analyzing all in one data set, you can, in 4 lines of code, make scatter plots for all of that, for that whole data set for every city individually, and notice patterns or how trends or how the relationship between these variables differs within all those different cities. So there's a lot more that would be great to talk about if we had more time, but we're getting kind of close to the end of the time we have. I know that a file was distributed to everyone that has all of the content that we covered here today, as well as a whole bunch of other tips and tricks. So you can take a look at that and see things we didn't maybe have time to go over. But the last thing we'll kind of do for the next 5 minutes or so is we'll see how we can use all of these ideas that we've looked at and kind of combine them all into sort of a realistic scenario. So what I've done here is I've made this plot that's, I think, a pretty good representation of an analysis that you might typically do in the real world. So this is using the same data we had, but you see that we have this plot where life expectancy is on the x-axis, country is on the y-axis. Each point represents the life expectancy for a given country. So Iceland is has the highest. Haiti here has the lowest. It says that the most recent data for each country was used because, remember, in our data set we have multiple years for each country. And then each of these color points is color coded by the continent. So this sort of red is the Americas and blue is Europe. So what we'll do is we'll take 5 minutes and figure out how we can reproduce this plot, because there's a lot of different things that went into making this plot. And by seeing how we can combine all these ideas together, we'll see how we can use all these ideas in a way that's pretty realistic for an analysis. So if I wanted to make this plot, the first thing I would do is say, okay, well, I know this uses the Gapminder data. So how do I make a plot like this? And it's obviously kind of overwhelming because there's a lot that goes into it. But the first thing I kind of notice is that life expectancy is on the x-axis and countries on the y-axis. So let's start there and see where that gets us. So we'll start with Gapminder. Again, we use the pipe. And then I'm going to use the exact same thing as we made for the scatter plots before. Life expectancy was on the x-axis, and then country was on the y-axis. So if I run this, we'll see if this gets us close at all to making this plot. And it does to some extent, right? We see that we have a lot of data here, too many countries actually, but we have life expectancy here. So we're starting to get on the right track. Now, one thing we can see from looking at this plot is that it only includes data from the Americas and Europe. So that sounds like a filtering step. So we can use that filter here and say, we want to filter where the continent is in, and then, what was it? The Americas? Yeah, the Americas and Europe. Oops. So we'll use a pipe here. So now we're doing a filtering step before making the plot. So now if we run this, we'll see that this actually gets us closer, because now I can see there's only countries from the Americas and from Europe. So that gets us one step closer to making this plot here. So now let's try putting these points on this line or on this plot. So while we know how to do that, we want to use this geo point. And let's see. So we can see this helps a little bit, but it's not quite what we want, because we can see we have multiple points for each country. And we can see if we look back at the plot, we don't have that. We only have 1 point per country. And we can see that there's a note here that says the most recent data for each country is used. So again, that sounds like a filtering step. So let's add another filtering here. Now, if we knew that all of this data was from a particular year, like let's say we knew it was all from the year 2002, we could just do that. But it doesn't say that it's from a particular year. It says that it's from the most recent data within each country or by each country. So to do that, what we're going to do is use a group by. So we'll just write this out. So we'll say group by country. Oops. So let's talk about this here. So we have Gapminder, we're filtering for the Americas and Europe, and then we're going to group by country. And what we're going to do is we're going to say we want the max year. So what this is doing is for each country, it's finding the maximum or the largest year within that country, and then it's only going to give us back data from that country. So for example, if Canada, the most recent data was from the year 2020, this would be 2020, and then it's going to say it's only going to give back data from the year 2020. If another country had data from the year 1995 and that was its largest year, then it will give us back the data for that country from 1995. And after we do that filtering within groups, we want to turn that grouping behavior off, because everything we're going to do after that is for the data set as a whole. So let's see what this gets us, and if it gets us closer to where we want to be. So this is great. Now we have each point, we have 1 point for each country here, but there's sort of two big things we need to do. One is these aren't ordered in any way, and they're also not colored according to continent. Now for continent, the coloring we know how to do. We want to just add a color equals continent. And because we only have 2 continents, America and Europe in our data set, should give us what we want. Perfect. So now we have the Americas and Europe here. The last thing to do is to order these from largest to smallest to make it a little bit more readable so we can see what's going on. And I haven't shown you how to do that yet, but what we're going to do is use our mutate function, because what we want to do is sort of rearrange the data so that it's arranged in the way that we want. So we're going to say mutate, and we're going to want to mutate the country variable. So we're saying country equals, and then we're going to write a function here that tells our how to rearrange the data. And I haven't shown this function yet, but it's really cool and very useful. It's called FCT reorder, which means factor reorder, or categorical variable reorder. And then what we're going to do is first tell it the variable we want to reorder, which is country, and then we're going to tell it the variable that we want to reorder by. So we want to reorder it by life expectancy, or in other words, we want to arrange life expectancy, each country by its life expectancy. So we'll type in life expectancy. So it's going to reorder country by life expectancy and then save that back as the country variable. And now when we run this, we see that essentially we have the original plot that we looked at here. There's a couple things like the titles and the labels that we need to change, but I've shown how to do that, so I won't do that here. You would just add on the labels and go ahead and put whatever you want in there, including a title or a subtitle or that kind of thing. But you can see how in maybe 8 lines of code or so, we've started from our raw data, we filtered it as a whole data at the whole level, at the level of the entire data set. We've then done some grouping at the level of country. We've filtered within country. We've ungrouped that data. We've mutated that country variable so that it's ordered in the way that we want. And then we've used our plotting functions. And by chaining all these different functions together that on their own are very simple and not particularly interesting, we can see how we can use that to make a plot that is interesting and tells us something about on the nature of this data set and about the world. So I'll just click zoom and we can look at it in a little bit more detail. But it's interesting because we see that there's a large difference in life expectancy. Some countries have a very high life expectancy, some have very low. And we can see that within the top 15 or so countries, all of those are from Europe, except for this one country here, that's Canada. So again, just to summarize, using all these ideas really lets you combine them in, you're only really limited by your imagination for how you want to use them. So I think that's it probably for the amount of stuff that we can go over. Time's running out, but I encourage you to look at that file that has, again, everything that we've looked at here, as well as a bunch of additional information, so that when you want to kind of go further in R, there's resources there for doing so, and for sort of increasing your skills and learning more about how to use R for data science. So yeah, thank you for your attention, and we might have time for a couple of quick questions. I can just look through the chat. Oops. I'll just quickly look through the chat here and see if there's any questions. Someone asked if, oh, sorry. If anyone wants to jump in and just turn their mic on and ask a question, you can. I don't see any questions that haven't been answered as I scroll through this. So if someone has a quick question, feel free to ask. The one thing I'll mention too is as we do these workshops, we're always interested in people's feedback. We have a quick survey here. If you're interested, you can take it. It just has a quick few questions. There's just 4 questions actually about what you found useful and what you might like to see in future workshops. So I see a question here, how to bring in the data. So yeah, there's a function. And if you look in that document that I sent around, it shows you how to read in your own data. So it's just one function. It's called read_CSV, or you can use another function for reading in Excel. There are functions for reading in SAS documents or SAS data sets or SPSS data sets. So it's very easy. It's one line. You use that little arrow or that assignment operator to save it as a name. So it could just be data or anything you want. And then you're able to use everything we talked about today on your own data, which is really nice. And yeah, someone asked where the Gapminder data set is being stored, and Tyler answered that. It's just when you install that package, a package can either have code or data for the most part. And that package just has that Gapminder data set. And there are some other data sets loaded into R. If you run the function data and then an open and close parentheses, that will bring up a little page that shows you all the data that's loaded into R. There's little data sets of like Star Wars movies and that kind of thing that you can look at. Yeah, someone said that they haven't received the document. I'll just put my email in here and you can contact me. Yeah, I'll do that in just 1 second. I'll put my email in there and I can send that out to anyone.
Okay, well, thank you very much, Matthew, and I hope everyone found this session really, really useful. And if you do have any follow-up questions or you need to get in touch with Matthew, you can contact us at manitoba@ipac.ca, IPAC, IPAC, as it sounds, and we'll transmit any questions that need to go to Matthew, or obviously you can contact Matthew directly. But beyond that, thanks very much. And we hope to see you at another IPAC event soon.